Here we discuss the another important numerical that is related to the physics. First numerical that is when force and displacement are in opposite direction, then the work is said to be positive, negative, infinite, and maximum. We know that when the force and displacement are in the same direction, then work is positive. When they are opposite direction, then work is negative. So here we write that if force and displacement are in the same direction, then theta is equal to 0 degree, and we know that for work done formula that is W is equal to F dot D. If we remove the dot sign, so it becomes Ft cos theta, and here we put the value of theta that is 0, Ft cos 0, cos 0 is equal to 1, so work is maximum when the force and displacement are in the same direction. Now we discuss the second case. Second case is if force and displacement are in opposite direction. When they are of opposite direction, then the angle is 180 degree. Put in this formula, work done that is F into D cos of 180 degree, cos of 180 degree that is -1. So work is minus F times D. So here we calculate that work is negative when the force and displacement are in the opposite direction. So our correct option is option B, that is the work is negative. Now we discuss the second MCQs. In the second MCQs, they ask that in a step-up transformer, if the secondary voltage is increased by a factor of 10, the current in the secondary coil will be, so here is the variety given data, that is the secondary voltage that is increased by a factor 10 by the primary voltage. Vp is represent the primary voltage and Vs the secondary voltage. Here we know the formula of current, Is our Ip and Vpa our Vs. Is our Ip. We know the secondary voltage value, that is 10 times the primary voltage. So ratio of the secondary current by primary current is equal to 1 over 10. So here we write that the secondary voltage is decreased by 1/10 of the primary current when the secondary voltage increased by a factor 10. So here we write that the current in the secondary coil decrease by a factor of 10 when we increase the secondary voltage by 10. So here is the correct option is the equal to the 1/10 of the primary current in the transformer. The current in the secondary coil will be the 1/10 of the primary current in the transformer. Okay, now here we discuss the third numerical, that is the when a droplet reach terminal velocity, acceleration is 0, variable, not change, and negative. So here we write that the terminal velocity is constant speed when droplet reach terminal velocity is constant speed when droplet reach this velocity. So here we take the droplet. This is the droplet. droplet reach this terminal velocity when the upward drag force become equal to the downward gravity force. So when droplet reach the velocity, then upward drag force that is the Ft balanced by the balance by force of gravity F G. So at this point net force is equal to 0. So when the net force is equal to 0, according to Newton law, that is the F is equal to ma, when net force is 0, so ma is equal to 0 and a is equal to 0. So acceleration is 0. So our correct option is the option A. When the droplet reach the terminal velocity, its acceleration is 0.